Hey guys, so here's the notes for 6.6. We're going to be talking about solving radicals. Okay, so how do we solve a radical? Well, we always need to make sure we get the base to be isolated. So the base can either just be the variable with the exponent, or it could be basically a factor with the exponent. So anything, when you have the variable or factor with the exponent, you need to make sure anything that is before it or after it, you need to get rid of first, and then you can go ahead and solve. So here, if we look, we have 4x to the 2/3 equals 36. Now, what's going to happen here is notice that we have a variable with an exponent. That is our base. So what we need to do is make sure it is isolated. So anything before it, anything after it, we need to get rid of it. Notice that we do have a 4 in front of it, and it's being multiplied, so the opposite would be dividing. So now I have x to the 2/3 equals 9, okay? Now, our next step we're going to do is we're going to rewrite our rational exponent in radical notation. So this is going back to the very beginning of our unit. So remember, so x is our base, 2 is the exponent, and 3 is the root. So we have the cube root of x squared, okay? So now what we're going to do here, now for this, you could have the square root either inside or outside. The radical is kind of up to you what you would like to do. We're going to go ahead and we're going to keep it outside. And the reason I want to do that is because we want to make the values smaller than bigger. There we go. Okay, so now what we are doing, since we rewrote it in radical notation, is we're going to get rid of our square and the cube root. So the first step is to get rid of the square. Well, how do we get rid of a square? We use square root, so I have to square root both sides. So when I do that, I now have the cube root of x equals, now anytime we take the even root, how many solutions do we get? We get 2, so don't forget that. That is also something you guys learned at the very beginning of this unit. So the square root of 9 is going to be plus minus 3. Now, we need to get rid of the cube root. What is the opposite, or we could say inverse, of a cube root? That's going to be cubed. So now, our cube root and cubes, they cancel each other out because they are inverses. So I get x equals, I do 3 cubed, that gives me 27, and you do need to keep the plus minus sign. So I get plus minus 27 as my solution. Okay, let's go ahead and do another one. So example 2, we have 3x to the 3/2 equals 375. So once again, don't forget, make sure you isolate your base. In this case, once again, our base is going to be the variable with the exponent. So anything before our x to the 3/2, we need to get rid of. So here we only have the 3, okay? So now I'm going to go ahead and divide both sides by 3. So now I'm left with x to the 3/2 equals, and you can just do this in your calculator, 375 divided by 3. That gives us 125. Now we're going to rewrite this in radical notation. Now what I would like you to do is go ahead and pause the video and rewrite this in radical notation so you can test yourself to make sure you know how to do that. Okay, let's see what you got when you rewrote it in radical notation. So x is our base, 3 is the exponent, and 2 is our root. So we have the square root of x to the 3rd power, okay? And that's equal to 125. So now our next step is we need to get rid of the power of 3, or the exponent of 3. So the inverse or opposite of a cube is a cube root. So our cube root and 3, they cancel each other out, so I'm left with square root of x equals, and this is where you can plug it into your calculator. So we're kind of doing stuff that we did at the very beginning of our unit. So you may want to have your calculator. I'm going to show you once again how you can plug this into your calculator. Okay, so remember, anytime you need to do a radical, okay, we can go to the math button. So this is using the graphing calculator if you're using it. Your scientific is going to be a little bit different, okay? So I go to my math, and notice for number 4, it's my cube root. So I do that, and I place 125. Now notice, because my root is odd, since 3 is an odd number, remember with odd roots we only get one solution. So here we don't need to have the plus minus. So we get 5. So the cube root of 125 is 5. Now I need to undo my square root. Remember, the opposite or inverse of a square root is a square. So I square both sides, okay? So I'm left with x equals, and I just do 5 squared, which gives me 25. And because we squared it, we don't need the plus minus. That's only when you take the even root, okay? Okay, let's go ahead and do the next problem. Okay, so we have x plus 3, and that entire thing is taken to the 5/2 equals 32. Now notice here how this is different. The last two problems we just had the variable to the exponent. Now we have an entire factor. So this is x plus 3 is called a factor. So this entire thing is our base. So what we need to do is see, is there anything before or after it we need to get rid of? Well, in this case, we do not, okay? So now we are going to go ahead and rewrite in radical notation. Okay, once again, go ahead and pause the video and rewrite x plus 3 to the 5/2 in radical notation. Okay, let's see what you got. So x plus 3 is our base, 5 is the exponent, and 2 is the radical. So 2 is going to be our root. So we have the square root of x plus 3, and that whole thing is taken to the 5th power. And that equals to 32. Okay, so now to undo a power of 5, we do the inverse, which is going to represent as a 5th root. So whatever your power is, you just do the root of it, and that's the opposite. And vice versa. So whatever the root it is, then you take it to that exponent, okay? Now, once again, we can plug this into our calculator if you don't know the 5th root of 32. So here, what we'll have to do first is put the number 5, go to math, and go to number 5. So that allows us to do the 5th root. So I have the 5th root of 32, and I get 2. Remember, this is an odd root, and with odd roots, we only have one solution, so I don't need the plus minus sign. So now I have the square root of x plus 3 equals 5. Now let's undo that square root. So opposite or inverse of a square root is a square. So now I have x plus 3 equals 5 squared, which is 25. And then our last thing we need to do is move the 3 over by subtracting. So I get x equals, it looks like 22 there, okay? Whoops, and I just noticed I made a mistake here. So let me go back. I just noticed that when I did my 5th root of 32, I said it was 5, but if we look at our calculator, it's actually 2. So let me kind of redo this. Sorry, guys. So the 5th root of 32 is 2. So we're actually going to square that. So that actually gives us 4. Now, once again, I go ahead and I subtract 3 from both sides, so I actually should get x equals 1 as my solution. There we go. Okay, let's go ahead and do the next one. Okay, now this is what I want you to do. I want you to pause the video and try this one all by yourself. Okay, let's see what you got. So once again, this is like our example 3, our last one. Our base is an entire factor. So anything before or after it, we need to get rid of it. I do notice I have the minus 7. So what I need to do is, the minus 1, I need to add that to the other side to get my base isolated. So I now have x plus 2 to the 3/4 equals 8. Now I rewrite in radical notation. So x plus 2 is my base, 3 is the exponent, and 4 is the root. So I have the 4th root of x plus 2, and that's all being taken to the 3rd power, which equals 8. So to undo my exponent of 3, or to the third power, I need to take the cube root on both sides. So now I have the fourth root of x plus 2. Now, once again, you can just plug this into your calculator if you don't remember. 8 is a perfect cube if you don't already know. So hopefully you do know your perfect cubes, okay? So here we can just go to math, go to number 4, and then do the cube root of 8, which gives us 2 again. So let me hopefully write this correctly so we get 2. Now remember, because we have an odd root, we don't have the plus minus, because with odd roots, you only get one solution. Now I'm going to take this whole thing to the fourth power, and 2 to the fourth, you can plug that into your calculator. Hopefully you already know how to do that. So my power for my fourth root cancel each other out. 2 to the fourth gives me 16, and now I just subtract 2 from both sides, and when I do that, I get 14 as my final answer. Okay, make sure you guys watch the next part. We're going to continue to solve radical equations.